Hey everyone, welcome back. Today we'll be looking at the work stretch. So when we're looking at work problems, there are two main ways I like to do it. The first way is to use tables, and the second way is to create variables, but being very clear about the units on your variables. So let's jump right in to question number 3. 3 workers wire 4 light fixtures in 20 minutes. At this rate, how many hours will it take for 6 workers to wire 24 light fixtures? So here I think we should use a table. So in the table we'll have 3 things: workers, light fixtures, and minutes. So there are 3 workers for 4 light fixtures in 20 minutes. So we want to first double the amount of workers to 6. So let's make this 6. And if we have more workers, the amount of time it takes them to complete the same amount of light fixtures actually decreases. So in this case, we'd multiply by half or divide by 2 to get 10 minutes. And now we need 24 light fixtures, well, with the workers staying the same. So this is multiplying by 6. And if we have more light fixtures, that's more work. So it takes more minutes. Multiplying by 6, we get 60. Therefore, the answer is 1 hour. So remember, in these problems, always use logic and don't get confused whether it's inversely proportional or standard proportions. So we'll look at one more problem, and then you guys can try it out on your own. It took Sasha 15 minutes to fully inflate a bounce house for her daughter's party, but she didn't notice that it was slowly leaking air. This slowly caused the bounce house to fully deflate after 1 hour. How many minutes would it have taken Sasha to fully inflate the bounce house if air had not been slowly leaking out at the same time? Here I will show you guys the second technique. So the second technique is creating variables. So we know that one of the variables will be how many minutes it takes Sasha to fully inflate, because that's what we want to know, right? So n minutes equals Sasha without deflation. That means that 1/n of bounce house is filled every minute. However, we know that the bounce house fully deflates after 1 hour. So that means every minute 1/60th deflates. So that means 1n minus 160 would, and this unit is, remember, bounce house per minute, let's say. And we will know that this is equal to the total amount of time reciprocal, because that's the rate. 1/15th of the bounce house per minute. Now this is a standard equation. So to solve this, we'll multiply both sides by 60 and n, because 15 is a multiple of 60, so this is the best way. We get 60 minus n is equal to 4n. We get 5n is equal to 60, and n is equal to 12. Therefore, the answer is 12 minutes. So you guys can try these problems out in the URL that will be shown right after this. Thank you all for watching. I'll see you guys in the next video.